Hello, this is Ed from PracticalNetworking.net. Welcome to a new video series where I'm going to teach you about access control lists. This series is meant to be the last set of videos you'll ever have to watch to understand this concept. This is the first video in the series where we will be answering the fundamental question, what are access lists? At its core, an access control list is simply a tool you use to identify traffic. How you apply the access list then determines what the access list is actually doing. For example, if you apply an access list to an interface, then any traffic that is identified by your access list is being permitted through that interface. This is the most common application of an access list, but there are many other use cases for an access list. For example, if you apply an access list to a network address translation configuration, then whatever traffic is identified by the access list is processed through NAT. If you apply an access list to a VPN configuration, then whatever traffic you identify with your access list is then encrypted and sent through a particular tunnel. If you apply your access list to a route map, then whatever advertisements match your access list are being accepted by your routing process. If you apply your access list to quality of service, then whatever traffic matches your access list is going to be prioritized or deprioritized. So there are these and many other ways to apply an access list. Again, an ACL is simply a tool on a Cisco router used to identify traffic. Now, for the purpose of this video series, we're going to be focusing on access lists applied to interfaces, because this is the most common use for an access list. We'll be using this topology to talk through the various concepts. Our topology features a router in between the inside segment and the internet. We have a couple hosts on the inside segment and a couple hosts on the internet. Now, when you apply an access list to an interface, that access list is sometimes referred to as a packet filter. The idea there is any packets being sent out by your inside host are going to be matched against this access list to determine whether the router likes those packets or doesn't like those packets. So to talk through it, let's go ahead and shoot some packets over. Let's have host A shoot a packet to each one of the servers in our topology. In both cases, these packets have a source IP address of host A's IP address because host A is sending these packets. This top packet has a destination IP address of the top server, and this bottom packet has a destination IP address of the bottom server. In both cases, the source port is randomly selected by the client, in this case host A. Now it's not explicitly listed in this illustration, but we can assume that this is a TCP packet. This top packet is destined to TCP port 80. This means that that is probably a web request, and this bottom packet is destined to TCP port 443, so we can assume that is an HTTPS request. Now we're going to use these two packets to talk through various concepts for access control lists, starting with the two types of ACLs that exist. There are two types of access control lists on a Cisco router. They are standard and extended. The difference between these two is simply which fields in the packet they are using to identify particular traffic. A standard access list is only matching on the source IP address, which means I can match both of these packets by identifying traffic with the source IP address of 10.00.11. That's the only option you have with a standard access list. Now this does create a limitation because it only allows you to provide complete trust or complete distrust. So here's what I mean by that. Let's say you had a requirement that said allow host A to speak to this top server, but don't allow host A to speak to this bottom server. Well, with the standard access list, all you can do is say either permit the source IP address 10.00.11, in which case host A can speak to both servers, or deny the IP address 10.00.11, which means host A is not allowed to speak to any server. So that is a limitation of standard access list, is that you can only provide complete trust or complete distrust. That is why an extended access list exists. An extended access list allows you to filter on many more fields, 5 of them to be exact. The source IP address, just like a standard access list, but also the destination IP address, the source port, the destination port, and the protocol. The key benefit there is you can create access list entries that say allow host A's source IP address to speak to this server, but deny host A's IP address from speaking to this server. So you can be much more granular in how you match traffic. So these are the two types of access lists that exist. You can create either of these types of access lists and then apply them to a particular router. Now when you apply them, you can only apply them once per interface, per direction, and per protocol. So let's talk through that. By interface, I mean the actual physical interface of a router. If you recall, our router had two interfaces, one of them facing the inside segment and then the other one facing the internet. Well, I can apply an access list to a specific interface. Now why this is important is because depending on which interface you're going to apply your access list to, the packet might look a little different. For example, let's just say this router is performing network address translation. That would mean these two packets on the other side of the router might look a little different. Notice the source IP address has changed. Well, if I'm applying an access list to FA01 and I want to match on the source IP address, this is the source IP address I need to match. But if I'm applying my ACL to FA00, then this is the source IP address I want to match. So it's important to know where you're going to apply the access list before you actually write the access list statements. The other thing to consider is the direction the packets are going in. To discuss it, let's go ahead and get rid of this yellow packet, and let's focus on this blue packet for a minute. This blue packet is the packet that host A sent to the server. At some point, the server is going to respond. When that server responds, the packets are going to look like this. The response traffic is simply a flipping of the source and destination in the initial packet. Notice the source in the initial packet is the destination in the response packet. Either way, notice that both of these packets are being processed against one interface, FA01. The difference is one of those packets is going out of that interface, and then the other packet is going in to that interface. So when you're applying your access list, you have to choose not only what interface you're applying it to, but also the direction. That's going to affect how you write your ACL statements. For example, if I want to match this packet, I'll be matching traffic as it comes in to FA01, and I'll be matching against, say, this source IP address. Whereas if I wanted to match this packet, I would still apply the ACL to FA01, but I'd be applying to traffic as it goes out of that interface, and I'd be matching on this source IP address. The last thing to consider of where you're applying your access list is the IP protocol. And by that, I simply mean IPv4 or IPv6. A single access list will either only filter IPv4 traffic or IPv6 traffic. You can't have a single access list filtering both. So if you wanted to filter both v4 and v6 traffic, you would have to create two different access lists and apply them to a particular interface in a particular direction. Now I'll be looking at the application of access lists to router interfaces in more details in a later video in this series. For now, the key takeaways from this video are these right here. We discussed that an access list is simply there to identify traffic, and then how you apply the access list determines what the access list is doing. We then discussed that an access list applied to an interface is sometimes called a packet filter, and that you can only apply an ACL once per interface, per direction, and per protocol. And finally, we discussed the two different types of access lists that exist, and the difference between them are the fields that they use to match traffic on, with a standard access list only matching on the source IP address, and the extended access list matching on source IP, destination IP, source port, destination port, and protocol. In the next video, we'll be looking at the syntax to configure access lists on Cisco routers. But as far as this video's, your key takeaways are on your slide right now. I hope you enjoyed this video. I want to thank you for watching, and we'll see you in the next one. Hello, this is Ed from PracticalNetworking.net. Welcome to another video in the video series on access control lists. This is video 2. We'll be looking at the syntax for configuring a numbered access list. In the first video, we answered the question, what are access lists? We define them as a tool you use to identify traffic. We talked through how when you apply an access list to an interface, you can call it a packet filter, and then a packet filter can only be applied once per interface, per direction, and per IP protocol. We then defined the two types of access lists that exist, them being the standard access list and the extended access list. In this video, we're going to be looking at the syntax to configure access lists on Cisco routers. Now there's two sets of syntaxes you can use to configure access lists on a Cisco router. Those two ways are numbered access list and named access list. You can use either set of syntax to configure either access list. In this video, we're going to pick apart the syntax for numbered access list. In a video that follows, we'll do the same for named access list. Here is the syntax for configuring numbered access list on Cisco routers. Notice I'm giving you two sets of syntax, one for standard access list and one for extended access list. These commands configure a single line in a standard or extended access list. Now we're going to step through each part of these commands together. To configure any numbered access list, you're always going to start with the command access list. That's simply the first word to indicate to the router you're configuring an access list. Following that, you're going to provide an ID number. This ID number is what links multiple access list entries together. Each access list entry is an ID number and then a match statement, and then another ID number and a match statement, and then an ID number and a match statement, another ID number and a match statement. What links all of these entries together is that ID number. That's the purpose of this ID number over here. It allows you to link multiple entries into the same access list. In fact, sometimes each individual entry is referred to as an ACE. ACE stands for Access Control Entry, and a series of ACEs creates an access control list. That's somewhat archaic terminology, but you might see it in random documents online. Either way, that's what an ID number does. Now, the ID number is also how you will refer to the access list later on in the configuration, when you apply the access list to a particular purpose. In a numbered access list, this ID number must be a number, but the number you choose is very significant. If you choose the numbers 1 through 99, you're configuring a standard access list. And if you choose the numbers 100 through 199, you're configuring an extended access list. That's how you determine whether you're configuring a standard or extended access list. It's based upon the ID number that you use. This means that you can configure about 100 of each type of access list on every Cisco router. Typically, you won't need more than that. But just in case you do, there's an additional set of ID numbers you can use to configure either a standard or extended ACL. So if you use the ID numbers 1 through 99 or 1300 through 1999, you're configuring a standard access list. And if you use the ID numbers 100 through 199 or 2000 through 2699, you're configuring a numbered extended access list. So that's the purpose of the ID number, which now brings us to the action field. This field can be one of three items. It can either be a permit, which says you're accepting traffic for a particular purpose, or you can list deny, which means you're rejecting traffic for a particular purpose, or the last option is you can simply list a remark. When you use the action of remark, it turns the rest of the syntax into a free text field, and you can type whatever you want. You can say something like, I created this access list on such and such date, or in response to such and such ticket number. It's just a simple comment. These two, however, are actually processed against traffic. This permit and deny statement are relative to how the access list is applied. For example, if you apply an access list to an interface, then the permit is saying I will allow this traffic to go through the interface, and the deny is saying I will not allow this traffic to go through the interface. But if you apply this access list to network address translation, then the permit is saying I will translate packets which match this ACL. And the deny is saying, I will not translate packets which match this ACL. But that packet might still be allowed through the interface. So keep in mind, this permit and deny are relative to how you've applied the ACL. Next, we have the protocol. Now notice there is no protocol in a standard access list. The standard access list can only filter on the IP protocol. Whereas in an extended access list, I can filter on different protocols. So this field is how you specify which protocol you're trying to match. There are a few different options here, one of which is simply IP. If you list IP in the protocol section, you're indicating to the router that you're matching all IP traffic. You can also match on the TCP or UDP protocols. If you specify one of these, you'll be able to specify ports later on when you get to the source and destination. You can also list the protocol ICMP to match pings and traceroute, and there's a slew of other protocols you can use, like GRE or these IPsec protocols and so on. Keep in mind, this field does not mean ports. Ports will be specified later on if you specify TCP and UDP as the protocol. Which finally brings us to the last three fields. Now the source in a standard access list and the source or destination in an extended access list are specified using the same syntax, so we can talk about all of them at the same time. These fields follow this syntax. You must specify some sort of IP addresses, and you may specify ports. Now to specify IP addresses, you would use this syntax. To specify a single subnet, you would specify the network ID and then the wildcard mask. To specify a single IP address, you would use the keyword host and then list the IP address. And then finally, to specify all IP addresses, you would simply use the keyword any. Here are the three options you have for this field, which is a part of these fields in the syntax for the ACLs. Now in this video series, we're not going to be unpacking wildcard masks. We did create a separate video discussing wildcard mask at length. If you're unfamiliar with the concept of wildcard mask, definitely check out that video. There'll be a link in the description. That said, let's move on to the ports section. Now remember, ports can only be specified in an extended access list. You cannot specify ports in a standard access list. Either way, if you choose to specify ports, you have a few different options. To specify a single port, you can use the keyword EQ and then list that port number. The EQ here stands for equals. You're saying the port must equal such and such. To specify a range of ports, you would use the range keyword, and then you would list the starting port number and the ending port number. Keep in mind, this is an inclusive range, which means if you list a starting port number of 20 and an ending port number of 25, you're specifying to match 6 different ports. Now most of the time, when you're specifying ports, you'll be using that guy right there. Occasionally, you'll be using that guy right there. But there are 3 other options which are pretty rare to use, but are important to know about to give you a full understanding of the configuration of access list. Here are those options. You can specify GT to say the port must be greater than a certain port number. You can specify that the port must be less than a certain port number, or even not equal to a certain port number. So all those are options you have to specify this section of the source or destination of an extended access list. Now note that we're using brackets in the syntax over here. That means that the port section is optional. So if you omit the port, if you don't put anything in here, you're matching on all ports. Okay, so now that we've talked through every single field in the syntax for numbered access list, it's time to actually configure some together so you can see them in action. In the next video, we'll be configuring access list entries to match some of the packets in this topology. But that's it for this video. The key takeaway is understanding each of the fields in the syntax for numbered access lists. I hope you enjoyed this video. I want to thank you for watching, and I will see you in the next video where we will configure access list entries together. Hello, this is Ed from PracticalNetworking.net. Welcome to another video in the video series on access control lists on Cisco routers. This is video 3, where we'll be doing a demonstration of the configuration of numbered access lists. In the last video, we stepped through each of the fields in a numbered standard access list and a numbered extended access list. In this video, we'll be configuring access lists together to match some of the packets in this topology. We're going to configure an extended access list as if it were being applied right here on that router, which means we'll be able to match traffic coming in from the inside out to the internet. Just like we explained in the last video, to configure an access list, we're always going to start with the command access list. So I'll jump into global configuration mode and type in access list. Then I'll specify an ID number. Now we want to configure an extended access list, which means we have to choose an ID number between 100 and 199. For simplicity, we'll just go with 101. Now I have to specify an action. If you recall, there are 3 possible actions: permit, deny, and remark. We'll start pretty simple and just start with a remark. Remember in the last video, I said that if you use the action of remark, the rest of the syntax is simply a free text field, and you can apply any comment that you will want. I could say something like, my first ACL, and the command will take. This allows me to document my access control list if I need to. But of course, since this is just a remark, I'm not actually matching any traffic. So now let's actually match this packet right here. Again, I'll start with the same command, access list, and we'll use the same ID number, 101, so that it all comes to be a part of the same access list. The action here is going to be permit. I'm going to go ahead and allow this packet through. Now I get to specify the protocol. For this one, I'm simply going to specify the IP protocol. I'm going to match any IP traffic that matches between host A and this top server over here. I'm going to keep it simple and do it just by IP address. So I'm going to specify that I want to match a source IP address of 10.00.11 and a destination of 54.4.4.7. If I hit enter here, you'll see that this line follows the syntax we described in the last video. We have the command access list, the ID number, the action, the protocol, the source, and the destination. Now notice we specified the source and destination using the host keyword. I told you there are 3 options for how you specify IP addresses on a Cisco router. One of them was specifying a single IP address using the host keyword. Next, let's do another entry where we specify an entire subnet. We're going to permit all IP traffic from the inside network to this bottom server down here. To do that, again, I'll start with the command access list. I'll use the ACL ID number 101. This is also going to be a permit statement. The protocol will also be IP, except here I'm going to put in the network ID and the wildcard mask that correlates to a /24 network, which is 0.0.0.255. And as my destination field, I'm going to add the single IP address of the server at the bottom over there, 45.5.5.8. So here we provided an example of specifying a single IP address. We've also provided an example of specifying a subnet. Finally, let's give you an example of specifying the any keyword. This will match all IP addresses. We'll go ahead and create another entry in access list 101. This is also going to be a permit statement. This time though, let's match the protocol ICMP. This will match pings and trace routes and those types of traffic. For our network, we can say that any source can send pings to any destination. So we'll just use any as both the source and the destination. This is telling the router that anybody sending ICMP traffic is accepted and allowed across this network. So far, we've configured 4 access list entries together. Let's see how those look in my configuration. If I do a do show run, and I pipe for the section that starts with access list, I'll see what I've just configured. Here are the 4 entries that I've just configured, and you'll see they match what we typed in pretty much exactly. Now those are some pretty basic access list entries to simply show you some of the syntax in action. Notice we didn't specify any ports though. So let's go ahead and add a couple more entries that do specify ports. To start, I'm going to create an access list entry that's going to match this packet exactly. It's going to match that packet in the most specific way possible. So again, I'm going to start with the command access list. The ID number is going to be 101. I'm going to continue adding entries to the same access list. The action is going to be permit, but this time the protocol is going to be TCP. In this illustration, it's not listed, but we can simply assume that this is a TCP packet. For the source section, I'm going to match this entire first line over here. The IP is going to be a single IP address, 10.0.0.11, and the port number must equal 7777. And then for the destination section, I'm going to match this line exactly. The IP address is going to be a single IP address, and the port number is going to equal port 80. This access list entry has just matched this packet in the most specific way possible. Remember how I told you that extended access lists can match across 5 different attributes of a packet? Well, this one line is proving that by matching across all 5 of them. We have the source IP, the destination IP, the source port, the destination port, and the protocol. But let's talk about it for a second. When host A shot this packet out, it randomly picked the source port 7777. In fact, every time a new connection is made, the client is going to pick a new random port number. So it's great that we were able to match this packet explicitly, but it's not going to match any future TCP port 80 packets sent by host A. So it's rare to see an access entry where you're matching on both a source port and a destination port. Often, when you're trying to match a particular type of traffic, for example, web traffic like this packet is, you're only going to match on the destination port and you're going to omit the source port. Which means typically that access list entry would look like this. It started out with the same command, same action, same port, except when specifying my source, I'm not going to specify a port number. What that is doing is saying match all ports. The destination part will look exactly the same to specify that I'm matching exactly destination port 80. Omitting the port in the source allows for my router to accommodate any random port that host A picks whenever it's sending web traffic to this IP address. So this is typically the way you would see an access list that's matching a particular port number. Now keep in mind, if you're matching the response traffic, which means if you're trying to match this packet right here, then you might end up seeing the port number specified on the source side to match this right here, and then the destination part omitted to account for whatever random port number might have been selected by host A. But for our purpose, we'll continue looking at just the outbound traffic. So let's take a look at everything we've configured so far. I'm going to go ahead and do my show command from before to take a look at our access list. Notice our access list has 6 lines. One remark, a couple permit IP lines, a permit ICMP line, and then some permit TCP lines. So at the moment, I've got all permits. Now there's still a question we haven't answered, and that is, what happens if a packet shows up on our router that doesn't match any of these entries? Well, from the router's perspective, these entries are explicitly telling the router which packets to allow through. If a packet shows up that doesn't match one of these explicit permit statements, the router is going to take a restrictive stance and say, if you didn't explicitly tell me to allow the traffic, I'm going to deny it. This is called the implicit deny, and it exists at the end of every single access list. Even though you don't see it, at the end there is a simple deny IP any, which will prevent any other traffic from coming through the router interfaces. So again, these are all explicit permit statements, and at the end of every access list is an implicit deny statement denying all traffic not specifically permitted in the access list itself. So technically, at the end of this access list, everything else is being dropped. Now just for the sake of showing you a deny statement, we're going to go ahead and configure a deny statement to deny a particular type of traffic. Specifically, we want to deny any NTP traffic from host A to that bottom web server down there. So NTP stands for Network Time Protocol. It uses UDP port 123 for its communication. So we're going to create a new deny statement in this access list that's going to deny this packet right here. Well, just like before, we'll start with the command access list. We'll add it to ACL 101 to continue adding to the same access list. This time, the action is going to be deny. The protocol is going to be UDP. Again, it's not in the illustration, but let's just go ahead and assume that this is a UDP packet. And now we specify the source. We're going to specify the source the way we did over here, where we don't use a source port number. Because again, every time host A creates a new NTP connection, it's going to re-randomize the source port number. We'll specify the source IP address, however, as host A. The destination is going to be the IP address of the server at the bottom, and then the destination port is going to equal 123. The idea is this deny statement is going to match this packet. Okay, so let's go ahead and take a look at our show command again to see the entire access list. Here is everything we have configured, and we did indeed configure this deny statement to accurately match this packet. But there's a problem. This packet is still being allowed through. Let me tell you why. The way packets are matched in an access list is based upon what's called first match. Meaning, when this packet shows up on this router interface, the router takes a look at the first entry in the access list and tries to see if there's a match. Well, in this particular case, the first entry is a remark, so we're not even going to look at that line. So it'll then look at the next line. The router's going to ask itself, is this the IP protocol? Yes. Is the source 10.00.11? Yes. Is the destination 54.4.4.7? No. So we don't have a match here, so now the router is going to look at the next line in the ACL. Is the protocol IP? Yep, because the UDP protocol is carried within IP, so this is still an IP packet. Is the source in the subnet 10.00.0/24? Yep. Is the destination 45.5.5.8? Yep. This packet matches this line, and therefore this action is going to be taken. So even though we configured this correctly, we have a problem because this line will match this packet first. To fix this, I would have to have this line appear above this line, or alternatively, this line appear below this line. This is an important fact about access lists, is that they are processed based upon first match. So we just went through a few configuration examples of a numbered extended access list to match traffic in our topology over here. We covered the basic configuration of access lists, and then we also covered two specific important points. The first is that at the end of every single access list is an implicit deny. The idea is any traffic not explicitly permitted is assumed to be undesired and therefore dropped by the router. And the second is that the order of the entries in the ACL matter. ACL entries are processed based upon first match. So there's one last thing I want to show you. Let me pull up our configuration again and let's see if we can fix this. Remember, we said the problem was this more specific deny statement needs to happen before this less specific permit statement. So what we can do is simply remove this entry and reconfigure it at the end. So what I can do is take that command, put a no in front of it to blow away that entry, but we're going to have a problem. If I right now do my show run command again, you'll notice everything has been blown away. One of the limitations with numbered access list is that when you do a no on a particular entry, you actually blow away the entire ACL. In order to reorder individual lines, what I would have to do is reconfigure the entire ACL from scratch in the correct order. That is a limitation with numbered access list that doesn't exist with named access list, which we're going to be looking at in the next video. The key takeaway for this video is understanding the demonstration of the ACL entries we configured, as well as understanding the implicit deny and that the ACL entries are processed on first match. I hope you enjoyed this video. I want to thank you for watching. I'll see you in the next video as we looked at named access list and some of the additional features they provide above numbered access list. Hello, this is Ed from PracticalNetworking.net. Welcome to another video in the video series covering access control list on Cisco routers. This is video 4, where we're going to explore the syntax of configuring named access lists. In the last video, we picked apart the syntax of configuring numbered access list. We also went through a bunch of configuration examples for numbered extended access list. In this video, we'll be looking at the syntax to configure a named access list. You'll see that the syntax is largely the same. Here's the syntax for configuring named access lists on Cisco routers. Now, a lot of the fields that we already understand in the syntax for numbered access lists are simply repeated in named ACLs. In fact, if we color code the correlation, you'll see that the source and the source and destination in numbered access list is the exact same as the source and destination in named access list. You'll see that the protocol is the exact same thing as it was in extended numbered access list, and the action in all cases is exactly the same. You still have the three options: remark, permit, or deny. The ID number field is just a little bit different. In a numbered access list, the ID number had to be a digit, had to be a number. Whereas in a named access list, you can specify the ID as a number or a name, which means you can name your access list something like giraffe or penguin or whatever you'd like. The command is also a little different. To configure a numbered access list, you just use the command access list. To configure a named access list, you use the command IP access list. But it works the same way. The command is just a little bit different. So you'll see between numbered access list and named access list, the syntax is largely the same. There's actually only two differences: that word right in there and the sequence number right there. So let's talk about them. When you create your named access list, you explicitly define them as either standard or extended. So those concepts of standard access list and extended access list still apply. But in a named access list, they're not reliant upon the number you choose as the ID number. Remember, in numbered access list, 1 through 99 is a standard access list and 100 through 199 is an extended access list. Well, that's not the case with named access list syntax. You simply define the ACL as either standard or extended directly in the command itself. Which brings us to this field, the sequence number. Recall that the order of entries in an ACL is significant. By default, when you add an entry to an access list, it appears at the end. Now this creates a limitation if you need to add something in between two other lines that exist. This sequence number field allows you to control exactly where a new entry appears. You can specify that a new entry should appear at any line number you want. That's the benefit of that sequence number field. Now note that it is an optional field. That's what these brackets mean. That means if you don't put it, it'll simply appear at the end. But you can control that by specifying a number in that field. So that takes care of talking through the fields in the named access list syntax. At this point, you might be asking yourself, if the fields and syntax of a named ACL are so similar to a numbered access list, what's the point of named ACLs? Great question. Named ACL syntax provide additional features which don't exist in numbered ACLs. In fact, do you remember that issue we had in the last video where we couldn't remove individual ACL lines from the numbered access list without blowing away the entire ACL? Well, that problem goes away if you're using named access list. You ought to understand that these tools were initially created a long time ago and have evolved as more features have been thought of and added. We went from standard access list, which only filter on source IP address, to extended access list, which filter on 5 different fields. In the same way, access lists were initially implemented with numbered ACL syntax. And the next step in the evolution is the named ACL syntax we just discussed. Other than the feature we just mentioned, there are other features in named ACLs that don't exist with numbered ACLs, and we'll be unpacking them all in detail in the next video. The key takeaways for this video is understanding the fields in named ACL syntax and how they are different from or similar to numbered ACL syntax, and finally, that named ACLs include features that don't exist with numbered ACLs. But that's it for this video. I hope you enjoyed this lesson. I want to thank you for watching, and I'll see you in the next video as we go through a demonstration of the configuration of named ACLs as well as some other features. Hello, this is Ed from PracticalNetworking.net. Welcome to another video in the Access Control List video series. This is video 5, where I'll be giving you a demonstration of the configuration of named access lists on a Cisco router. In the last video, we picked apart each of the fields in the syntax for named access list. If you're unsure what either of these fields mean, go and review the last videos. In this video, we're going to pick up right where we left off in the last video by reconfiguring our numbered access list as a named access list. Recall in video 3, we went through the demonstration of configuring numbered access list, but we ran into that problem where this deny statement was appearing after this permit statement. We attempted to reconfigure this permit statement at the end by using the no command, but what that ended up doing is blowing away the entire access list. In this video, we're going to start by reconfiguring this numbered access list as a named access list. Now the syntax for named access list is very similar to numbered access list. You'll see just how easy it is to reconfigure a numbered access list as a named access list. We're going to take what we already configured and throw it into Notepad. Then we're going to go to the top and add this definition statement first line. So we'll start with the command IP access list. Then we'll specify that this is an extended access list, and then we'll provide a name. For this ACL, we'll simply call it PracNet. Then this part is identical to what we had in numbered syntax. So all we have to do is get rid of this access list 101 at the beginning. And we can do that by doing a simple find and replace. We'll replace every entry of access list 101 with just the space, hit replace all, and that's all we have to do to reconfigure our ACL as a named access list. You'll see if I take that and put it back into my router, the router accepted all those commands. And now, if I do a show run section access list, we'll see the named access list that we just configured. So you'll see that the syntax for configuring a named access list is pretty much the same as we've already covered in a numbered access list. But there are some additional features that named access lists provide that doesn't exist on numbered access lists. And that's what I want to focus on for the next few minutes. First, let's give ourselves a little bit more room to work. Earlier, if I scroll up, we tried to remove this line, which was this line. And then in the numbered access list, it blew away the entire ACL. Well, let's see what happens if I try and do the exact same thing with my named access list. This is the line that I want to remove, and I actually want to re-add it below this line. So I'll go into global configuration mode, and then into named extended configuration mode. That's what all this means. It's extended named access list configuration mode. And I'm simply going to do a no on this line right here. Now, if I do my show command again, you'll see that the access list still exists, except for the one line that I'd removed. Remember, that wasn't an option in numbered access list. In numbered access list, it blew away the entire ACL. I can simply re-add this ACL by copying and pasting it, and it'll automatically appear at the end by default. I'll again do my show command, and there's the entry we just added. Notice now it is correctly showing up after this deny, which means finally the deny that we tried to add 2 videos ago is doing what it's supposed to do. So far, we've been using this command to view our access list. We've been looking at the configuration in the running configuration of any lines that are in the section access list. But there is another command you can use to verify your access list. That command is simply show access list. Notice when I type this command, it's telling me I have an extended IP access list called PracNet, and here are the entries in that access list. Notice at the beginning is a number. This number is a sequence number. Remember, I told you named access lists have the sequence number that you can use to place ACL entries in a specific location. Well, by default, every time you add a new ACL entry, they show up in increments of 10. You'll notice over here we skipped 20 between these two. That's because we had just removed the permit statement that was in between these two and re-added it down below. That's why it seems like we skipped 20. But otherwise, they go in order and in increments of 10. This allows me to add new entries exactly where I want them to be. Also, this allows me to remove individual entries without having to do a no on the entire line, like I did up here. So let me show that to you. Notice this line over here. Remember, this line is matching a particular packet hyper-specifically, so specifically that it would never match any other packet. So remember, we did this line to show you an example of matching on source ports and destination ports. Well, let's go ahead and remove this line, but instead of copying and pasting the entire line, we can simply do a no on sequence number 40, and that'll take care of removing that line. So again, I'll go into global configuration mode, and then I'll go into extended named access list configuration mode, and I'm simply going to remove this line by typing in no 40. Now, if I do my show access list, we'll see that line 40 is gone. The other thing the sequence number lets me do is allows me to add a new entry at a specific location. This ACL entry is denying NTP traffic. Well, let's just say I have to add another deny entry that denies SSH traffic from this host to this host. Well, if I add it at the end, this less specific permit is going to take priority, and that traffic will actually still be allowed. So I need to add the new deny statement in between these two entries. So again, I'll jump into named extended access list configuration mode, and I'm going to say I want this new entry to appear at line 65. So I'll simply put the line number 65, and then everything else is exactly as we've done before. The action is going to be deny. The protocol, we said SSH, so that's going to be TCP. The source is going to be host 10.0.0.11. We will leave the source port omitted to say match any source port. We'll say the destination is host 45.5.5.8, and the destination port is going to equal 22 for SSH traffic. If I hit enter here, and I do my show command, we'll see that this new entry that I just added now appears in between entry 60 and 70, right at line 65. So this sequence number allows me to add entries to a specific line. Now that's some pretty cool functionality for named access list, but the thing that's really cool about named access list syntax is that you can actually use named syntax to modify numbered access lists. Let me show that to you. Let's go all the way back up to where we had configured our numbered access list before. So this is what we had configured before, right before we blew it away inadvertently by trying to remove that one line. Let's go ahead and reconfigure everything we had by simply copying and pasting it into our access list. And now, if I do my show run section access list command, we'll see this is our named access list, and here is the numbered access list which I've just reconfigured. But check it out. if I do show access list, which is the second show command that we learned, notice both my named access list and the newly configured numbered access list are showing up with these sequence numbers. Notice the one I just configured goes in increments of 10 because I just configured it using all the defaults. I can actually edit this numbered access list using named syntax. Let me show you. So named syntax looks like this. I'll type IP, then access list. This is an extended access list, and the ID number is 101. That's what this is right here. And then from here, I can get all the cool benefits of named syntax in numbered ACLs. For example, remember when we tried to blow away that line and re-add it later on, but it accidentally blew away the entire ACL? Now I can simply do no 20, and this one line is going to be gone. If I do my show command again, you'll see line 20 is now gone from my numbered access list. If I wanted to make that entry reappear at line 67 or something, I would simply type the sequence number, just like a named sequence, and then the action, protocol, source, and destination would be exactly the same. I'm simply going to copy and paste it from before. Oops, it was line 20 right here. I'm simply going to copy and paste it from before. And now, if I do my show command again, we'll see that it appeared at line 67. So you can use all those cool features of named access list on numbered access list as long as you use the syntax for named access list. Now, the last thing I want to show you with named access list has to do with these sequence numbers. I told you that by default, sequence numbers go in increments of 10. That means you have the option of inserting up to 9 other entries in between 2 entries that were added at the default increment of 10. Well, what happens if you need to add more than that? Or what happens if you don't like how you seem to be skipping ACL entries every once in a while, or things look a little uneven? Well, what you can do with named access list is resequence all the numbers at whatever increment you want. The command for that is IP access list resequence. Then you specify the ID number or name. So for this example, let's go ahead and resequence the numbered access list. And then you list the starting sequence number. We'll go ahead and say 3000. And then you list the increment. And for this example, we'll go ahead and say 11. Now, if I do my show access list command again, we can see that ACL 101 starts at sequence number 3000 and goes in increments of 11. This lets me respace out all the entries in my access list in case I need to do more insertions and deletions than I had initially planned for. If I wanted to resequence something to its default sequence numbers, I would use that same command, IP access list resequence, and then specify the name. And I would start at 10 and go in increments of 10. And this would make my ACL called PracNet appear as if it had been configured in its default configuration from the beginning. So that is the resequence command. So we spent some time giving you a demonstration of named access list syntax and showing you some of the cool new features that named access lists provide over numbered access lists. Some of those features included that named ACLs allow you to remove individual lines. Named ACLs allow you to insert lines at the desired location using that sequence number. Named ACLs allow you to modify numbered access lists as long as you modify them with named sequence. And finally, named ACLs allow you to resequence the numbers as you please. Now there is one additional feature that named access list provides that numbered access list doesn't. And that feature is that named access list allows you to configure IPv6 ACLs, which we'll be covering in the next video. The key takeaway for this video is understanding these 4 features of named access list and the configuration demonstration of named access list that we did. I hope you enjoyed this video. I want to thank you for watching, and I'll see you in the next video where we discuss IPv6 access lists. Hello, this is Ed from practicalnetworking.net. Welcome to another video on the Access Control List video series. In this video, we'll be looking at IPv6 access lists. In the last video, we stepped through a demonstration of the configuration of named access lists for IPv4 on a Cisco router. We also talked through these additional features that named access lists provide that numbered access lists do not provide. The last thing we had mentioned is that there is one additional feature that named access lists provide, and that is named access lists allow you to configure IPv6 ACLs. The syntax is just a little bit different, so let's start by showing that to you. Now we're going to leave the syntax up for IPv4 named ACLs just to show you that it's largely the same. But here is how you would configure an IPv6 named access list. Notice most of the fields are identical. There's actually only 3 differences, and I've highlighted them for you on this slide. The first difference is the command itself. To configure an IPv6 access list, you would use the command IPv6 access list. Whereas to configure an IPv4 access list, you would just use the command IP access list. The second difference is actually what's missing right here. In an IPv4 access list, you have to specify whether the IPv4 access list is a standard access list or an extended access list. Notice that's gone in the IPv6 ACL. That's because in IPv6, all access lists are extended. There is no standard access list for IPv6. Now that's a good thing because there's nothing you could do with a standard access list that you couldn't also do with an extended access list. So you may as well get used to using a more granular and more thorough tool for the same job. Finally, the last difference is actually purely cosmetic. In IPv4, if you wanted to add an ACL entry to a specific line number, you could use the sequence number by typing the line number directly. In IPv6, you have to first type the word sequence and then the number. Otherwise, the sequence number works the exact same thing. It simply looks a little bit different in the syntax, so it's just a cosmetic difference. So now that we've looked at the syntax for IPv6, let's go ahead and configure some IPv6 access lists together using the same topology that we're familiar with. So this is the same topology that we've used before, same host, same IP addresses. This is using IPv4. So let's go ahead and get rid of these packets and add IPv6 addresses to this topology. What we're doing is called dual stacking. Notice we're running both IPv6 and IPv4 on the same topology. Now that these hosts have IPv6 addresses, we can shoot off some IPv6 packets. And then we can pull up our router to configure IPv6 access list to match these packets. We'll pick up right where we left off in the last video. In the last video, we had played around with modifying numbered access lists with named syntax and configuring named access lists. In this video, we're going to step through the same sequence of ACLs we created in video 3, except this time we're going to be doing it with the IPv6 addresses. So we'll start off by jumping into global configuration mode. And then here, I'm going to type in IPv6 access list, and then I'm going to give it a name. And I'm following the sequence of commands in this line right here. We'll keep it simple for the name. I'm going to call it PracNet v6. This puts me in IPv6 ACL configuration mode. Notice we don't have an N here because there is no numbered access list. All access lists in IPv6 are using named syntax. Now we get to this line over here. Now if you recall, back in video 3, the first thing we did was created a remark. So let's go ahead and do that again. We'll add a comment indicating my first IPv6 ACL. Again, remarks work the exact same way. They're just there to leave comments or notes. They don't actually affect packets in any way, shape, or form. The next thing we did in video 3 is we created an access list that matched traffic from host A's IP address to the top server's IP address. Now we're going to do the same thing, except we'll be using the IPv6 addresses. So again, the action is going to be permit. The protocol is going to be IP. The source is going to be host, and then we'll be using host A's IP address to match this packet right here, 2001, 2, 3, 4. And then the destination is going to be this guy right here, which is the top server's IP address over here. 3AC1, 54447. And that's it. We have just configured our first IPv6 access list entry. The next thing we did in video 3 was configured an IPv6 ACL to match an entire subnet. So let's go ahead and do that next. Again, it'll be a permit statement, and again, our protocol will be IP. To match a subnet in IPv6, you would again specify the network ID. In IPv6 terminology, this is called the prefix. And then you can specify the mask directly using / notation. From there, the destination will look the exact same thing. We'll allow the entire subnet to send IP packets to this bottom entry over here, bottom server over here. 3AC1. The next thing we did is we created an any rule for ICMP traffic. That'll look exactly the same. Permit ICMP any. Nothing too special there. So that takes care of showing you 3 access list entries, some that are matching on individual IPv6 addresses, some that are matching on IPv6 networks, and some that are matching on any ICMP v6 traffic. Now let's get into TCP and UDP packets and start configuring ports. If you recall, back in video 3, the first thing we did was we showed you an extremely specific access list entry that was matching across all of these attributes. Well, let's go ahead and do the same thing just to show it to you, even though we know that that's not typically how ACL entries are written. So this is going to be a permit statement for TCP traffic. The source is going to match this entire line over here. So it's going to be the host IP address 2001.123.4a, and the port is going to equal port 6666. The destination is going to match this entire line over here. So again, the single host IP address is going to be 3AC1.444.7, and the port must equal 80. Again, you're seeing each part of this syntax played out. We have the action, the protocol, the source, and the destination. Now again, in IPv6, the source port is randomly selected, just like it was in IPv4. Again, layer 4 has not changed. So while this access list entry matches this exactly, it's not going to match the next TCP port 80 packet that is sent by host A. So let's go ahead and reconfigure that in a more realistic way. And honestly, we can simply just copy and paste everything and simply omit the ports in the source. I'll simply space through that just to make it easier to read and add the destination right there. Now again, so far all I have is a bunch of permit statements. Well, IPv6, just like in IPv4, has the implicit deny at the end. So anything that doesn't match these packets explicitly will be assumed to be denied. But just to show you, I'm going to go ahead and add a deny statement at the end, even though technically all packets at this point that aren't being matched by these first 5 entries are being denied. The action is going to be deny. The protocol is going to be UDP. The source is going to be the entire inside segment. And then the destination is going to be that bottom server over there. Oops. I just realized I forgot to add EQ port 123 at the end of that to match NTP traffic. So let me go ahead and know that line out and add it again, except this time I'm going to add EQ 123. If I do a show access list, this is the IPv6 access list we created. Now you'll notice it looks just a little bit different, so let's highlight those differences. Here is the IPv4 ACL we had created before. Notice the sequence number in IPv4 shows up at the beginning. In IPv6 ACLs, the sequence number is showing up at the end, but it works the exact same way. It's just a cosmetic difference. Moreover, notice the IPv4 ACLs match the IP protocol. We typed in IP when we were adding these ACL entries, but it automatically changed them to IPv6. That's because the actual command is IPv6, and Cisco's command autocomplete actually filled it out as IPv6. You can remember it as simply typing IP or IPv6. Either way, it'll work. It'll do the same thing. Finally, the same issue we ran into in video 3 still applies in this video. Notice our deny statement over here, while it is correctly configured to match NTP traffic, all NTP packets will have already been matched by that entry right there. Therefore, for this deny to apply, we either need to move this above this guy or move this below this guy. So what we can do is simply use the sequence number to know out this line. We'll go into IPv6 access list configuration mode, and I'll type in no sequence 70. That'll blow away this line, and I'm simply going to reapply it so that it appears between these two lines. These two lines have sequence numbers 20 and 30, so I'll go ahead and set this new one to appear at sequence number 25. And now I'm adding this optional entry over here, sequence 25, and then I can actually just copy and paste the rest of the statement because the syntax is exactly the same. If I hit enter here and I go back to show my access list, we'll see this is our deny statement now appearing at sequence number 25. And so that wraps up our demonstration on configuring IPv6 access list on a Cisco router. Now so far, all we've done is create access list. We haven't actually applied any access list to the interface. In the next video, we'll show you how to do that. The key takeaway for this video is understanding the syntax to configure IPv6 access list and realizing that they are very, very similar for configuring IPv4 ACLs, as well as following while we did the demonstration of the configuration of IPv6 access list above. I hope you enjoyed this video. I want to thank you for watching, and I'll see you in the next video where I'll show you how to apply access list to interfaces. Hello, this is Ed from PracticalNetworking.net. Welcome to another video in the Access Control List video series. In this video, I'll be teaching you the configuration to apply an access list to an interface. Do you remember this slide back from video 1? In this slide, we talked about how an access list is simply there to identify traffic, and that an access list by itself doesn't actually do anything. You have to apply the access list before it actually does something, and there are many different ways to apply the ACL. The most common of which is applying an access list to an interface. When you apply an access list to an interface, that access list is referred to as a packet filter. We unpacked all of this in the first video of this series. We also talked about how you can only apply an access list once per interface, per direction, and per protocol. So I'm going to show you the full extent of what that means. So far, we've only looked at the syntax for configuring access lists. Here is the syntax for actually applying an access list to an interface. Note that this first set of syntax is for IPv4 traffic. Either way, you would go into interface configuration mode, and then inside interface configuration mode, you'd use the command IP access group. You'd specify the ACL ID by number or name, and then you would list the direction that you mean to filter traffic for. So for our topology over here, if you wanted to apply an access list to FA00, the syntax would look like this. I'm using the command IP access group. I'm applying access list 101, and I'm having it match traffic as it's going into that interface, meaning anything being sent from the inside segment into FA00. Now for IPv6, the command is largely similar, but it looks a little different. The only difference is simply the first part, the actual command. In v6, again, you would go into interface configuration mode, and then the command to apply an access list is IPv6 traffic filter, and then you would again specify the ID number and the direction. So for our interface over here, it would look like this. Here, we are using the command IPv6 traffic filter to tell the router that we are applying an access list. The access list we are applying is the one that we called pracnet_v6, and we are again applying it in direction in, so it's matching any traffic going in to that interface. So that's the syntax to apply an access list to an interface. Now notice, in one interface, we've applied two access lists, one for each protocol, in a single direction. Both of them are direction in. If we wanted to max out every single way we could apply an access list to interface FA00, we would simply have to add two more access lists covering direction out. Here, we're adding another IPv4 access list, filtering traffic coming out of FA00, and here we're adding another IPv6 access list, filtering traffic going out of FA00. Both of those ACLs are matching traffic as they're coming out of FA00. So theoretically, that would be anything the internet is sending to our inside hosts. And that is the most number of access lists you can configure on a single interface. You are matching out every possibility of that line. And so that wraps up this video discussing how to apply access list to an interface. In the next video, we'll be answering the age-old question of where should you apply your access list. Specifically, we're going to unpack the ideas of applying access list closer to the source or closer to the destination. But that's it for this lesson. I hope you enjoyed this video. I want to thank you for watching, and I'll see you in the next video where we discuss the best place to apply access lists. Hello, this is Ed from PracticalNetworking.net. Welcome to the last video in the Access Control List video series for Cisco IOS routers. This is video 8, where we'll be answering the question, where should you apply your access list? To talk through it, we're going to use this topology. This topology has 3 routers and 1 host connected to each of the routers. We're going to try and accomplish this task of preventing host C from speaking to host A. Now we just learned how to configure access lists in the videos prior. So let's go ahead and configure an access list that's going to prevent traffic from host C. Now you'll notice this is a standard access list. We're going to talk about standard access lists first, and I'll talk about extended access lists later on in the video. This numbered standard access list is configured to deny traffic with a source IP address of 10.33.33. That's host C's IP address. The next line is meant to permit all remaining traffic. Now this is important because we only want to prevent host C from speaking to host A, and we don't want to inadvertently prevent host C from speaking to host B or the internet. Now we learned from prior videos that you can apply access list to any router interface. In videos 1 and video 7, we talked through how you can apply an access list once per interface, per direction, or per protocol. To accomplish this goal, we can apply this access list to any router interface on the path between host C and host A. So if we map out the path, this is what it would look like, which gives us 6 locations we can apply this access list. But only one of those locations is the best place to apply it, and that's what we're going to talk through together. Starting with applying the access list to router 3's interface right here, filtering traffic coming in. So if that access list is applied there, let's see if it's going to prevent host C from speaking to host A. When host C shoots off a packet, it's going to have a source IP address of 10.33.33, which means it'll match that line, which means it'll be denied. So we have successfully accomplished this goal. But you have to consider what else host C might be trying to talk to. For example, host B. Well, the path for traffic from host C to host B is still passing through this access list. And since it's still going to have a source IP address of 10.33.33, it's still going to match that first line and be denied. So if we apply that access list right there, we are inadvertently preventing host C from speaking to host B. It'll be the same case for the internet. If host C shoots a packet to the internet, that traffic is going to follow that path. And you'll notice it'll still cross our access list, which is configured to block any traffic with a source IP address of host C. Which means if the ACL is applied here, host C is also prevented from speaking to the internet. So it's great that we were able to accomplish that goal, but here you'll notice we have blocked more traffic than we meant to, which means this is not the best place for our access list. So let's move the access list to the next router interface in the path. Now we've moved it to router 3, filtering traffic out. Well, just like before, the path for host C to speak to host B, host A, and the internet is still crossing that access list, which means that access list is still going to successfully prevent host C from speaking to host A, but also inadvertently prevent host C from speaking to host B, and prevent host C from speaking to the internet. If we move it to the next router interface in the path, since the path for a host C to speak to any of these resources is still crossing our access list, we're going to end up with the exact same result. Host C cannot speak to host A, which is good, but host C is also unable to speak to host B or the internet, which is bad. So we've identified that here, here, or here is not the best place for our access list. So again, let's move the access list to the next router interface in the path between host C and host A. And here, you'll notice something a little different will occur. Notice now, the traffic from host C to host A is still in the path, so we are still able to successfully filter that traffic. But now, the traffic from host C to host B is no longer touching that access list, which means host C is now finally able to speak to host B. So we've made some progress, but we're still not done, because the path for traffic from host C to the internet is still crossing our access list and therefore still inadvertently being prevented. So let's again try the next router interface in the path. You'll see that if we apply the access list to router 1's interface direction in, it's going to be the same effect as we had it over here. Traffic from host C to host A is successfully being prevented. Traffic from host C to host B is successfully not being prevented, but traffic from host C to the internet is inadvertently being prevented. Which finally brings us to the last interface in the path. If we apply this access list to this interface direction out, you'll notice that the only traffic whose path goes through that access list is the traffic from host C to host A, which means we are successfully preventing host C from speaking to host A and successfully not getting in the way of host C speaking to host B or host C speaking to the internet. So we finally found the perfect place to apply that access list. Which means we can learn from this that when you have a standard access list, the best place to apply it is closest to the destination. Notice our goal was to filter traffic from host C to host A, which means host A was the destination, and the best place to apply that access list was as close as possible to host A. This way, it didn't inadvertently block more traffic than we meant to. So that takes care of explaining standard access list. But what about extended access list? Well, let's reconfigure our access list as an extended access list and step through the same process. Our numbered extended access list is granularly filtering traffic with the source IP address of host C and a destination IP address of host A. And just like before, we still have 6 different places we can apply that access list. So again, let's step through each of those locations and try and answer these 3 questions. Starting with this location right here, direction in on router 3. You'll notice the topology hasn't changed, which means the path for host C to speak to all these resources is the same. And if we apply that access list right here, each of those paths is going through our access list. But since now we are using an extended access list, this deny statement is only going to match specifically when host C is speaking to host A. Which means if we've applied the ACL right here, host C is indeed prevented from speaking to host A, but the traffic from host C to host B is going to have a different destination IP address. That's going to have a source of 10.33.33 and a destination of 10.22.22, so it's not going to match that line. It will instead match our permit IP any. Which means even though that traffic is going through our access list, it is being allowed through. And it's the same for the internet. Host C is able to send traffic to the internet because whatever it sends to the internet is going to have a destination IP address of whatever our internet host is, and not host A's IP address. So on the first place we've tried to apply our extended access list, we have successfully accomplished our goal. For the sake of thoroughness, let's go ahead and try the next location. Well again, even though the path for all these hosts is passing through our access list, since our extended access list is granular, it's only going to get in the way of traffic between host C and host A, which is exactly what our goal was. You'll find that no matter where we apply the extended access list, in all cases we have successfully accomplished our goal and not affected any more traffic than we meant to. That's the beauty of extended access list. Because they can be more granularly written, you can actually apply an extended access list anywhere you want. And as long as you write your access list as specific as possible, you won't accidentally filter more traffic than you mean to. Now there's a general best practice that suggests you should drop packets as early as possible. The idea there is if you know you're simply dropping packets from host C to host A, you might as well drop them right here to prevent these routers from processing unnecessary packets, which creates this rule of thumb for extended access lists that you should apply them closest to the source. This allows you to drop them as early as possible to prevent your network devices from processing traffic unnecessarily. So, we answered the question, where should you apply your access list? We learned that standard access list should be applied closest to the destination, and extended access list should be applied closest to the source. And if you're studying for a certification exam, this is what you should memorize. That said, I want to give you my personal recommendation for the real world. In the real world, I would recommend avoid standard access lists entirely. Extended access lists can do everything that a standard access list can, but you get the added benefit of the option to be more granular when necessary. So you might as well get used to using the better tool. And then you should apply those extended access lists wherever it makes sense. The idea there is to consider aggregation points. If this is your topology, then sure, applying an extended access right here makes sense. But if your topology is a little bit different, and now you're trying to prevent host C and possibly other hosts hanging off R3 and R4 to speak to host A, then maybe the best place for your extended access list would be right here or possibly right here. That's what I mean by consider aggregation points. Either way, that's it for this lesson. I hope you enjoyed this video, and I hope you enjoyed the rest of the videos in the ACL series. If you did, the best way to thank me is to spread the word about this content. The more people who see these videos, the more it'll encourage me to continue making training videos for you. I greatly appreciate any sharing you can do. As always, don't forget to like and subscribe. Otherwise, thank you for watching this video, and we'll see you in the next one.